describe about the limit,
Yes.
continuity,
And
continuity in limit. Okay. Okay. Today I'll continue the class with differentiate function of x. Calculus differential. Have you heard before? Differential.
yes.
Can you explain to me? Can you describe any implementation of differential case? Maybe in your daily activity. Can you tell me the implementation of differential? Maybe from your previous level of education, higher education, SMA. In Yaman, what we call high school? Yeah, high school. Yeah, high school.
Like Tanawiyah.
Sanawiyah. Sanawiyah. Oh, Sanawiyah Junior High School in Indonesia.
Senior.
Senior ya?
Yeah.
MTS. Madrasah Aliyah, Sanawiyah. Yang SD. Madrasah Ibtidaiyah. Oh ya, Ibtidaiyah. Sanawiyah, Aliyah. Aliyah High School. No?
No, high school Tanawiyah.
My bad. Okay. Have you heard about the differential in Sanawiyah?
Oh. Aku tahu sih itu. Aku tahu sih.
Actually, I don't understand what the differential is.
What I was SMP.
Ah, okay. Kalau yang lain, dia terus.
Ya.
Have you heard about differential turunan?
Yes.
This is one of the example of differential. Yeah, got it?
Yeah, I get from.
Okay. If a function of x we call y, or function of x equal to q of x plus 7x squared minus 5x plus 4. Then the when you try to differentiate this function,
3x.
Good. Yes, that's good. So you make my lecture easier. Okay. I think you have got this. I think, yeah, it's just for reminder. For the second derivative, the third derivative, and so on. Okay, we talk about the second derivative. Yes, you done this material. So, if the second derivative, third, and so on, we can use one method. We call it chain rule. Chain rule. You can imagine a chain. Yeah, the chain, we can differentiate a function and then differentiate it next for the rest of the request. Okay. This is the notation if you have to find the second derivative of x function, and this notation is you have to find the third derivative of x function. When you see this notation, then what you have to do? You have to calculate the third derivative of the function. Okay, have you heard it before? Have you seen it? Yeah.
Yeah, in high school.
Okay. The fourth derivative?
Yeah, it's about me, but here in Indonesia, I don't.
Okay, in the
Okay.
country.
Yeah.
The fourth and the fifth derivative? Have you done it?
Until we got in.
Okay. Have you calculated?
What?
Have you calculated?
Yeah.
Oh, okay. The others, teman-teman, pernah? What the implementation? Can you explain to me the explanation, the example of this kind of differentiation? The third level, the fourth level, and so on. Okay, you know the theory. Then the application now. What kind of application? Yeah.
I kind of I kind of forget about it.
Yeah. So,
No, I don't remember that much about it. So
okay.
I-
Never mind. Okay. Yeah.
Probably for the application is for calculating the in physics, calculation in physics.
Physics. Okay. What kind of calculation?
Velocity probably.
Oh, velocity. Okay. Velocity. Velocity. You got this velocity from the differentiate of
Distance.
Yeah.
And time.
the difference between okay, velocity,
Oh.
the ratio, the difference between distance and
Time.
2 times. This is the basic concept of differentiation. So when you differentiate the velocity, what kind of parameter that you got? What parameter?
The
When you
unit.
differentiate this velocity, this parameter.
The unit,
Yeah.
kilometer per hour.
Okay, kilometer per hour.
Meter per second.
Per hour, kilometer per second, or meter per second. What else? When someone requests, when someone requests you to calculate this velocity, then okay, calculate the differentiation of velocity 2 times what kind of parameter that you got.
The next derivative.
Yes.
Acceleration.
Acceleration. Have you? Yeah. Acceleration. When you calculate the differences of velocity to differences of
Time.
times. V. When you differentiate the velocity to times meter per second minus meter per second, and you divide by second.
Second.
What units? It equals to what units?
Meter per second.
Minus.
Point.
Ya, meter per second minus meter per second So with equal to meter per second. Then when you divide meter per second with second, then
Oh, yeah.
it equal to meter per second square.
Square.
What kind of unit is this? Acceleration.
Acceleration.
This is one of many examples of differential calculus. When you try to calculate the ratio between any number to any number else, so you got the margin. You know margin?
Marginal.
Yeah, marginal rate of return, marginal rate of production. Yeah, because in that concept you have to divide two difference between any value. Differences between A divided by differences in value of B, for example. What does it mean? This is the difference between the velocity between when the car achieved in x1 second to x2 second. There is the acceleration between this time and this time. Okay, so you got the meter per second.
Square.
Differences between the initial velocity to the end of velocity between time of interval x1 to x2. You get the point?
Difference.
Any question? The marginal production rate, for example, you have to calculate the manager ask you to compose any resource in the production shop. So tell me, which is better, 2 manpower or 3 manpower? So you have to calculate. If 2 manpower, the output X. If 3 manpower, the output is Y, for example. So you can calculate the differences between these two values. Then you make a decision which value is better. Use 2 manpower or 3 manpower. The unit of this calculation is unit per manpower. The increasing of manpower gives you how much the increasing of output of the production. Get the point? So this marginal rate of production will help you to make a decision of how much manpower that you have to use to optimize the production schedule. Can you imagine? That one of many examples of differential calculus. You know the theory, but when you have to use that theory, yes, that 2 examples describe you when to use this theory. Any question? Oke, nggak masalah. Kalian mau tanya, silakan. Pakai bahasa Indonesia, bahasa Inggris, terserah. Saya akan usahakan menjawab sampai saya nggak bisa jawab. I will explain to you until I have no idea how to answer the question. Oke, silakan. In English, Indonesian, no problem. I have to deliver this theory to you as long as I can. Any question? This method for if you have to differentiate the u function multiplied by v function, where u function is a function with x variables and v is the function of x variable too. When you find this case, so you can answer with function u multiplied by differentiate of function f of v to x, because v is a function with x, the variable of x. Then plus the function of v multiplied by the differential of function u to x, because u function u is a function with the variable of x. Is there any problem? When the case is function u function divided by v function, where u and v is a function with the variable of x, so you can answer this case with the function of v multiplied by the differential of u to x minus u multiplied by the differential of v to x, and you divide all the product, to v squared, the function of v squared. Okay, I think there is no problem with this method. Can you answer this 3 case? I think it's a simple one. First example. You differentiate the function of y to x, because y is a function with the variable of x. How about this form? How about this form? How to differentiate this form?
minus 2x and
Can we?
Minus 2x. Okay.
Any idea? Do you have another answer? Another method to solve this case, solve this problem from your high school, from your sanawiyah? Is there any idea to solve this problem?
Same.
For sure, with the same solution, same answer. Any idea? Any question?
Sama.
Next. Second problem. We can substitute the apa pembilang itu apa? Penyebutan denominator ya.
Numerator.
Pembilang numerator.
Numerator.
The numerator. The above product is we call it numerator. Numerator. Denominator. We substitute the numerator with u.
Mhm.
X squared plus 1. So the differential product of u to x is 2x. Then we substitute the denominator with v and the differential product of v to x is okay. We got this one. So we're ready to the method of when we found the case of two function divide each other. So yes, you can use this equation. V differential of u
2x.
2x 2x minus u
X squared plus 1.
squared plus 1 multiplied by
2x.
of
2x.
v 2x divided by v squared v. Any question?
In my high school, we usually write like Y accent. Is it allowed in
Yeah, pardon me.
like we use Y accent instead of
Oh,
the
Y accent. Yeah, Y accent. Right.
Yeah.
Yeah. This is equal to Y accent. The second derivative of Y is Y double accent. Any idea? Maybe any method to solve this case, this problem? You can use this equation if two functions divide each other. I think it's easy one, yeah.
Yeah.
How about this? Last example. Easy, right? Skip or we discuss about it? Skip?
Discuss.
Discuss. Okay. Okay. Just like remedial, okay? Last one is this one. Okay. Substitute the left one with it's here arbitrary. You free to make a notation of the substitution. Maybe A, okay. A for the left one. 3. So the differential product of function A to x is solve it.
3 times
3 times
x squared
okay.
plus 1, 3 minus 1. Yeah.
Or you can substitute the inside one. 2 times of substitution, 2 level of substitution. Okay, I'll give you example. A is okay. So B is x squared of x plus 1. So the differential product of B to x is x. Now A is B. The differential product of A to B is so the differential product of A to x is the differential of A to B multiplied by the differential of B to x. Okay. Differential a to b multiply by b to x. What is b? B is this product is different with this one. Is this one finished?
No,
No.
it's too hard.
Derivative.
Yeah. Maybe our friends have not finished the answer. Same answer. You can use whatever you want. If you think the last one is easier to guide you to get the answer, you can use this one as a direct method. It's up to you. Okay.
But where did that b go? Like from the equation, the x squared plus 1, where the b on the question?
B.
Like a is for the x squared plus 1 times power by 3, right? But where's the b?
Where's B?
Yeah.
B.
Is it like the
B just for the substitution to make easier for us to differentiate the function. Okay, we use B to call the x squared plus 1. We declare it for the first iteration of the answer. Okay, we substitute the left one with A. Okay, then we face a difficult this obstacle one. Yeah, if you can't imagine how the answer of this product, I think it's complicated one. So okay, I declare one variable that will help me to make this differential process look easier. So I declare B as the inside product of this bigger product. B is x squared plus 1. So the differential of B to x is 2x. Okay. Then we move back to the previous level. If we use B, so A is B power by 3. Okay? And we differentiate this A to B because A is a function of B. The answer is 3 multiplied B squared. Okay. Then we're back to the main level because we have to find out the differential of A function, the function of A to x. We find it by multiply this two function that you have differentiate. Differential of A to x is differential A to B multiply differential B to x. So you get this product. Mungkin ada yang belum jelas atau saya harus ulangi dengan bahasa Indonesia, nggak ada masalah. No problem. question? No? Clear? I think you've mastered this. I think you mastered it. Ah, the implicit function. Why we call it implicit function? Implicit, explicit. What is implicit means? What is explicit means? In easy way, I can describe the implicit function is the function where we do not know where is the dependent variables and the independent variables. When you see this function, which one is the dependent variable? When you see this equation, when you see this function, which one is the dependent variable?
The x square.
X square or y square?
Both.
Both. You can mention it to me. X or y? Or this one? X multiply y equal to 1. Which one is the dependent variable? In this case, the independent variable. Mention to me which one is the dependent variable. Dependent variables. Which one the dependent variables? Y or X? What is dependent variables? Dependent variables, independent variables.
It like
In this example, y will follow x for its value. So, is x follow any variables? No. X can be input with any number regarding to what kind of case that you have to consider. For example, if we try to compose the manpower, so X is the number of manpower, then we use X as integer, right? Not a ratio. Okay, so Y will follow anything that X said. So in this case, Y is dependent to X, and X is independent for any value of the number. In this equation, we do not know which one is independent variable nor dependent variable. So you can make y as a dependent variable to solve this equation, the differential product of these three example of implicit function. Okay, I will show you how to solve the problem with can differentiate this function as y as a dependent variable. Then you have to differentiate this function with respect to x. A constant,
0,
the differential product of constant,
0,
we move this product of left hand side to the right hand side. Any question? Next. Calculate the differential of this function with respect to x. So
2,
done. Next. This type of function refers to the theorem of the fifth or sixth theorem. This one, the multiply product. So you can use this equation to solve this problem. Substitute u as x or
V,
is that right? Or any idea? Done. Any question? Have you mastered this type of problems? Have you found it before? Is the difficult one? last example of implicit function x squared plus equal. Okay, this product in the middle one we solve with the fifth theorem of the slide. Okay, in the middle one. The left product, you bring it to the right hand side. So the different sort product is done. You just send me a card. Yeah. 5 of all. Oh yeah, thank you. Thank you. Not bad. Wait. Thank you. Is there any more correction? Maybe your teacher from your high school teach you easier one to solve this kind of problem, implicit function. You can show us. It's free for everyone here to share about the knowledge to solve this differential calculus. Okay. If you have an easier way to solve this problem, show to us. Is there any question?
Where did that x action go?
X,
X action, yeah, the top one, yeah.
this one,
Yeah.
the differential of x. What's the product of differential of x?
1x
One. Okay.
dx per x
One.
dx. X. Oh, hey. Okay.
Never mind. A detailed answer. Okay, thank you. Any else? I think the first meaning of math just up to the implicit function, and we will discuss about the transcendent function, just like trigonometry, sinus, cosinus, tangent, the differential of this trigonometry function in the next one day. Thursday. I will describe to you the other else of function, how did the other function like exponential, logarithmic function. Okay.